So I heard you first announce Zero at the local First Conf in Berlin last year. And this is like partial sync, which you're just talking about, has been a big part of the sort of local first problem space. It's like local first makes a lot of sense if you have a single player or like low sync app. It's like you're making a recipe book for yourself and maybe your family or something. The amount of data, like you were saying earlier, is small enough that like syncing is easy. You just keep the whole database like in the client. But like getting to bigger apps, say something like linear, where you have like many teams and a lot of data and whatever, you start losing all of that. So it was really exciting to hear you talk about partial sync and Zero and this terms, because like especially for the local first space, that's like one of the big sort of unsolved problems. So do you see like Zero fitting into the local first space in any other aspects or any other properties that like make it a good fit for that space? Or do you think like the partial sync thing is like really the sort of the real value of like what Zero provides from the local first standpoint?
So the partial sync is the new innovation in Zero. Existing sync engines, including Replicache, do have something that they call partial sync. And so we're not like adding this term to the discussion, but the partial sync that all existing systems provide is like very coarse grained and like very like inflexible and sort of insufficient for like the kinds of applications that, like, if you're trying to build Notion, like you can't really build it with these existing systems, or not practically. But like Zero does inherit some of the benefits from Replicache. Like Replicache had this new way to do conflict resolution that was new at the time. We called it like transactional conflict resolution, and sometimes we've referred to it as like server reconciliation. And so we like Zero inherits that, and that's an important benefit. And another thing that Replicache had that was like not Replicache isn't the only system that does this, but it was a really big benefit of Replicache, is like connecting to your existing backend. So some sync engines, you like have to use their server. And there's like even like things that are kind of close to sync engines, like InstantDB. I don't know. It's a synchronizing system, I guess is fair to say. But you have to use their backend. And I'm not like trying to throw shade here. Like I think those guys are doing really cool work. But like a lot of users really loved Replicache because it allowed them to use like common trusted tools like Postgres, or connect to their existing backend that had a lot of stuff in it, or like incrementally adopt because they have some existing application that's using like common tools. So yeah, those are the big benefits of Replicache, like the transactional conflict resolution and BYOB. And Zero inherits those and adds partial sync. Or actually what we call it is like query driven sync to distinguish from like the existing approaches to partial sync.
Yeah, so let's drill into that a little more. You have your own query language called ZQL. So how does that fit into the picture, and like how is that to use as a developer?
Yeah, so like, I mean, the core idea is like you're building some application, it's multi-user, it's got a lot of data. You can't sync all the data, and you only need to sync the data. You only want to sync the data the user's allowed to access. So how do you define like the data to sync? And what do you do if the user navigates to a different part of the app and they need new data, right? Well, like existing systems have ways to like structure the data that gets synced, but then like often it's not flexible enough to describe the permissions or to really describe like the intricacies of like the data that's needed. And then if you navigate sort of off the map and you need new data, like you need to do that quickly. You need to like, the app needs to like specify the new data that it wants and get it quickly. So the core idea of Zero is like you express the data that you want using queries. And there's no separate system that like where you specify what data to sync. The app just makes queries the normal way, like as if you were using any other, like as if you were using Supabase or like Firestore or something like that. Like in the client, the app makes queries, and those queries are reactive automatically. Every query in Zero is fully reactive. And that is like similar to what like Firestore and Supabase are. Well, Supabase, the queries aren't reactive, but in Firestore, the queries are reactive. And so there have been other systems like Rethinking that had reactive queries. So that part isn't novel. But then what's interesting is that we're not syncing the query. Like the queries aren't reactive. What's really happening is that the rows behind the queries are getting synced to a local client. And that client is like a real database. So the rows for each query are getting synced into a database. And then you can do new queries against that database. So once you've synced one query and you do another query that overlaps with the first one, any of the rows that came down from the first query are available to be instantly returned by the second query. And similarly, like if you change the data So you have one query open and you change the data in your app, the query that you have open will instantly react to the changes that you made locally. So the core idea is you build your app out of these queries, and the queries are reactive, and that we're syncing the data behind those queries. And what data is being synced is fully described by the set of queries that your app is currently using. And that's it. And that's how you build your app. And so in order to do this, we had to build a new query language, because we'll get into this in a bit, but we needed a streaming query language to do this efficiently. And so we built this query language called ZQL. It's very reminiscent to Prisma or Drizzle or Kaiserly, if you've used those. And you use it right from your app inside TypeScript. It's fully typed, and it's really nice experience. And it has all the power, basically the power of SQL, with some niceties added, like subqueries.
So that model almost seems like a render as you, or fetch as you render model, where I render components and it fetches as you go down the line. Recently in React talk, a lot of the talk has been around pulling your queries up to a shared space, or using a tool like Relay or Isograph to do that for you in the background. Does Zero have any of those properties where it kind of hoists things, or does it give me the ability to hoist things?
Yeah, this is such an interesting question. When we started Zero, we were very interested in this idea of co-located queries, where you put the queries inside your components, and then they're sort of aggregated up the tree like Relay does. And they're sent all at once to avoid waterfalls, right? Or another way to say it is we're very interested in the idea of co-located queries, and we wanted to mitigate the problems that come as a result of co-located queries, right? And so we built the query language. ZQL is a fundamentally composable system. It has first class subqueries, so you can aggregate the queries and build them up into a ball and send them all at once. But we haven't actually implemented the thing the aggregation yet. And partly that started as we haven't got to it. Building the core query language is very difficult. Building the sync engine is very difficult. It was we just haven't got to that part of the stack yet. But also we decided early on to drive the development of Zero with a dog food app that we've built, because we wanted to be really sure that we were building the right stuff, and the thing that we built could actually be used to build was a really good experience for building actual sophisticated apps. And one thing that we found as we were going along was we didn't need this query aggregation as much as we thought we would, as much as we expected that we would. And we actually built this whole bug tracker similar to Linear for our own use, and we haven't needed this query aggregation yet. And it's interesting to think about why. I could go into more, but I think the top level is we're fundamentally rethinking the architecture of apps. And a lot of the things that people are used to doing are fallout from the current architecture of apps. And so as you change this low level of the system, and the upper levels kind of change as a result, and it's kind of a mistake to assume that all the things that you currently need at the high level you will, or they'll take the same shape or whatever. So I could go into more details about that, but I mean, I guess the answer to your question is you don't need that stuff as much as you do today, because it's a sync engine.
Yeah, because most of that's probably dealing with the client server interaction and the overhead that's there. And if you have it all locally and readily available, it can be faster.
I mean, it's because you can reuse the data from other queries, right? So you think about your typical view, right? You have this query waterfall problem, but part of the issue is that you do one query, you get data back, and then you do another query, and that query might overlap quite a lot with the first one. But the client doesn't know that. And so every single query is just totally independent and disconnected from each other. And so you kind of have to aggregate the queries, because there's no way for them to share data. If instead what's happening is you send a query and you get the data back, and now that data is available for the next query, then a lot of flexibility opens up. Sometimes they just automatically overlap. Think about, you're building a music player, right? You see the track list, right? To render the track list, you needed the track information, right? Then you click on a track detail. You already have the track information. So maybe there's a few extra pieces of information that you didn't need for the track list, like the album cover or something like that. And that could come in asynchronously. But often, a lot of times, you already have the data that you needed for the next query. And then if you don't, then you can easily decide to preload some of the data. And as an app developer, you often know the general shape of the data that you need. And so you can put a preload query in, and that sort of fleshes out the rest of the covering, and then you need it less. I'm not saying it will work for every single case. And I think there could be cases for zero-based apps where you want it to load as fast as possible and we still want some of that aggregation stuff, and we might still build it. But we have just found that like it wasn't anywhere near as big of a problem as we expected. And like we already have like, I don't know, like 24 like people somewhere between development and production, like serious like projects, like after a month, and they haven't asked for it either. So we're just sort of building in order of priority.